Good evening, all. I'm Pramod Rawal, study of this course. I'm going to take problem solving session 1 on chemical reaction engineering 1, week 1 first chapter, kinetics of homogeneous reactions. The course tutor is Professor Vishwavardhan Mandals, Chemical Engineering Department, IIT Guwahati. So I think all of you have gone through the week 1 lectures which are available on some portals. This is a brief recap, introduction to chemical reaction engineering 1, chemical reaction and its classification, variables affecting the reaction rate, and expression of rate of reaction and types of rates. So based on that, I'm going to take some problems. So starting from the MCQ ones. So question 1. In a reaction, which of the following is true regarding the molecularity and order of the reactions? Options are given. Before going to the options, let's clear the what is the molecularity and order of the reactions. The molecularity means number of molecules involved in the chemical reactions. Right? A plus B. Here, two molecularity means A plus B. Two molecules involved in these reactions. And order of reactions are equal to A. Here, small a is a order of with respect to the C, and B is a order with respect to the CB. Or total order of reactions A plus B. So molecularity, it can have a value 1 to n3, and for order of reaction it can have fractional value as well as integer. Right. Now we go to the options. Molecularity and order has an integer as well as fractional values. The molecularity has an integer and fractional value, but order has a integers. So order has an integer and fractional value, but molecularity has only integers. Right. And here molecularity and order has only fractional. So C is the correct answer. Question 2. The unit of frequency factor in Arrhenius equations. As you all of you know the Arrhenius equation, K is equal to K naught exponentials E by RT. Here is a activation energy, R is a gas constant, T is a temperature, and K naught is a pre-exponential power factor, T is a rate constant. So this term is a dimensionless. So unit of K naught is a same as a rate constant. Now go to the options. Are the same as those of the real rate constants. This is it. So B depend on the order of reaction. It does not depend on temperatures and or a cycle component. So option A is a right answer. Question 3. The pyrolysis of ethane proceed with an activation energy of about 300 kilojoule per mole. How much is a faster is the decomposition at 650 degrees Celsius than at 500 degrees Celsius? Option are given 5 times faster, 7 times faster, 10 times faster. Similar. There he asks how to calculate the rate at 650 degrees Celsius compared with the 500 degrees Celsius. Here activation energy K given. Here you we have to use the Arrhenius law K is equal to K naught exponential minus E by RT, right? For two features T2 by K1 equal to RA 1 by T1 1 by T. Right. So E given R is a gas constant 8.314 joule per mole per Kelvin. Eight point three one four. Convert the unit of temperature degree Celsius to Kelvin. Six 50 plus 273. Right. Is a 7.58. Right. R R A equal to 7.58. So, 7 times faster compared to the 500 degrees Celsius. So answer B is right. Question for an elementary reactions A plus B gives products. The reaction rate is a 500 Kelvin each 10 times that at 400 Kelvin. Calculate the activation energy. Here is the elementary reaction gives. The rate equation directly proportional to the stoichiometric equation that's called the elementary reactions. Right. So here R2 is denoted for 500 Kelvin. The second reactions. 10 types are 1. Now, how to calculate the activation energy using Arrhenius law. Right. 1 by T1, T2, right? By L1, 10, T1, 4, T1 is a 400 Kelvin, that's 1 by 500. So E is 38.38 joule per mole. This is the activation energy of these reactions. Moving to the question number 5. For a chemical reaction, the ratio of rate constant at 500 Kelvin to the that at 400 Kelvin is 2.5. Given R is equal to 8.314 joule per mole per Kelvin, the value of activation energy. This question is similar to this one. So here given the rate constant. Here mentioned as the reaction rates. So T2 given 2.5 by T1 by T2. Right. Where equal to 15 kilojoule. Option C is right. So question number 6. The temperature dependence of chemical reaction rate in general can be written as K is equal to K naught into t raised to the power m exponential minus e by rt. What is the value of m from the collision theory, transition state theory, and the from Arrhenius law? So here is the expression given: k is equal to k naught t m l by rt. Right. So m is equal to 0, m is equal to half, m is equal to 1. So now put m is equal to 0 in these equations. K is equal to k naught, it is certain 1 x p by rt. This is a Arrhenius law. When m is equal to 1 by 2, equal to k naught 1 by 2, collision theory. When m is equal to 1, put in equation 1 is equal to k naught t exponential and the transition state theory. Now question number 7, from the collision theory the reaction rate is a proportional to option given. So here m is equal to 1 by 2. Question number 8, at a given value E by R, ratio of activation energy and gas constant, the ratio of the rate constant at 500 Kelvin and 400 Kelvin is 2. If Arrhenius law is used, what will be the ratio if transition state theory is used with the same value of ER? So how to calculate K2 by K1 using the transition state theory. So based on the Arrhenius law, temperature K2 by K1, K1 right equal to 2 by R 1 by T1 1 by T2. Right. Now based on transition state theory, T2 by T1 into right here 500 divided by 400 into, so these terms equal to the 2 to 2. So 1.25 into 2, 2.5. Right. Go to the option. So D is the correct answer. And moving to the question number 9, the activation energy of the reaction is 1,55,326 joule per mole. The rate constant of the reaction at a 300 Kelvin as a function of the rate constant at a 400 Kelvin obtained by the collision theory is. Here we have to use the collision theory, calculate the relationship between K1 and K2. Right. Here the activation energy given, temperatures given. K is equal to T 1 by 2 R2 temperatures T1, T2, T1, T2 by R 1 by T2 by T1. So given R 8.74 to T1, T2 given for that T1 given 300 Kelvin, and put the value here 1.5 into 10 to the power minus 7. So T2. Right. Option is a right. Moving to the question number 10. The rate of increase of number of bacteria under certain condition is proportional to the number of bacteria. If the number doubles in 4 hours, how much increase in numbers of bacteria can be expected after 12 hours? So in this question given rate of increase the number of bacteria. This rate of increase means dn by dt, right? Under certain conditions is proportional to the number of bacteria. Here n is the number of bacteria, right? Equal to dn by dt equal to dt. So if number doubles means dn it doubles in 4 hours. So how much increase a number of bacteria can be expected after 12 hours? So we have to calculate number of bacteria. Now take integration. So ln t t. Now at t is equal to 0, so c is equal to n is equal to n naught. C is equal to ln n by naught equal to the ct. Right. Okay. So 1 by t ln. Right. Now given n by n naught is equal to doubles in a t is equal to 4. So right. So t is equal to 1 by 4 n. Now at time 12 hours, so how much n by n naught? This is our additional questions. N by naught equal to right. So from this relations, n by n naught to exponential dt. Right. So here is a key value. Put the relation t. T. Well, it right. There is another approach to solve this. where T is equal to force N by N naught equal to 4 hours. So at by the so it now T is equal to 12 hours and by 1 8. So its number of vector can be displayed after 12 hours. Moving to the question number 12. A rocket engine burns stoichiometric mixture of fuels, liquid hydrogen in oxidant, liquid oxygen. The combustion chamber is cylindrical with a dimension 50 centimeter dia and 70 centimeter long. And combustion process produce 120 kg per second of exhaust gas. If combustion is complete, find the rate of reaction of hydrogen and oxygen. In this question, so we have to calculate the rate of reactions of hydrogen and oxygen. It are S2 and R O2. I have to find out. So here given dimensions, and here stoichiometric mixture of hydrogen and liquid, and it produce 120 kg of exhaust gas. Right. Do 1 by V S2 by dt or hydrogen RO2 1 by V by dt equal to right. Now first calculate the volume of cylinder. Just a second. 50 centimeter in length, 75 centimeter. Produce 110 kg. Second exhaust gas O2 and S2. So volume of cylinder by R square H pi by 4 is H 0.1178 meter cube. Now this is the stoichiometric mixture is 2 plus O2 is 2O. The molecular weight of hydrogen 2 kilo kg per kilomole. O2 16 and H2 18 kg per kilomole. Now H2O produce per second equal to 120 kgs divided by molecular weight of waters in kilomole. 6.6 kilomole. Right. The stoichiometric ratio 1 to 1. Right. This is equation 3. Now based on the equation 3, is to use 6.66 kilomole second and O2 use There is a 1 by, sorry, here 2.66, 3.33 kilomoles. Now, of reaction of hydrogen equal to 1 by 2.1178 volume of cylinder is 0.66 equal to 56.53 kilomole of hydrogen divided by meter cube of rocket per second. Similarly, for hydrogen 28.26 kilomole of O2 meter cube of rocket. Fifty-six point three kilomole meter cube of rocket into second. And for O2 will do 28.26 kilomole meter cube of rocket. Question number 12. A human being 70 kg consumes about 5,000 kilojoule of food per day. Assume that the food is all glucose and the overall reaction is glucose plus 6O2 gives 6 carbon dioxide plus 6H2O with release energy 2870 kilojoule. Find the man's metabolic rate in terms of moles of oxygen used per meter cube of person per second. There we have to calculate the rate of oxygen 5b 5dt. First, to calculate the value, below the density of persons. The density of person is 1000. So, the volume of person equal to 870 divided by density equal to 0.07 meter cube. Now to calculate these terms, dn by dt. So 6 moles of O2 used per mole of glucose with releasing energy 2870 kilojoules. kilojoule per day to 2870 kilojoule mole of glucose 6 mole of the blood glucose. So this is different. 10.45 mole of the blood. Now put this value in equation value and this value in equation once r 2 into 1 by 0.07 to 10.45 convert day into seconds 24 to 600 from 0.00172 mole of O2 use meter cube of person into second. This is the metabolic rate of person in terms of mole of oxygen used per meter cube of person per second. Moving to the last question, which is the correct statement from the following statement on the Arrhenius models of the rate constants k is equal to a to e is to the power e by rt. So option are given. So first, how to check by option Y. Option A is always a dimensionless. So here is a Arrhenius law. Right. So this is a dimensionless and A is the same unit as upper rate constants. So this is a false. A is a false. Now B are two reaction 1 and 2. If A1 and A2 and E1 greater than E2, then K1 greater than K2. Right. So K1, K1, K2, K2, K2. Right. If A1 equal to A2, K1, K2, K2 are equal to 2 minus 1 RT. Here, mention that E1 greater than E2. So this will be possible. K1 plus K2 equal to E minus E1 by E2 by RT. Right. So minus E1 by E2 less than 0. The exponential distance, then exponential of negative always less than 1. K1, K2 is less than, means K1 T less than K2. Right. But here mentioned in option B, K1 is less than K2. So this is also false. Now option C, for a given reaction, the percentage change K with respect to temperature is higher at lower temperatures. As you know, K is equal to RT, right? Equal to minus P by RT, right? Now differentiate with respect to the temperatures. P by RT square. 1 by P dt into d by t square. So here is a in the t is in denominator terms. So k change of k with respect to the temperatures is higher at lower temperatures due to the t in denominators. If t in numerators, so this change of k with respect to the is higher at higher temperatures. So option C is right. And D, the percentage change K with respect to temperature is higher for the higher. So this uh, answer does not depend on the E. Option C. So I cover all the question based on the first chapters. So if you have any doubt, please ask. If you don't have any doubt, can I close the decision? Okay, thank you all. We will meet on next Friday on next chapters.